So good time of day, everyone. Welcome to this new MLIR meeting. And this week, we're going to have a discussion about a new proposal for high-level machine learning-oriented dialects for MLIR. So Raghavan, please go ahead. The floor is yours.
Yeah, thanks, Mehdi. Hi, my name is Raghavan. We're going to talk about this proposal for a new high-level ML dialect here. I'll start with a brief introduction. I'm part of the ML compiler team at Cruise, and we are working on building a compilation stack for ML models using MLIR. And the goal is to do code gen for GPU and accelerators. And in the short term, we are focusing on PyTorch inference on NVIDIA GPU and a custom accelerator. I'm sure everyone here is aware of this discussion, but I just wanted to put a link to the thread and the proposal document here. But I also wanted to take this chance to thank everyone. There's a lot of good discussion and interesting points there in both the thread and the document. So thanks a lot for that. That was very helpful in coming up with the design. And yeah, these are the main discussion points that we thought we could address, but we can take any other points if you guys think something else is more important to begin with. But maybe as a first thing, I probably want to get this out of the way first. Like, I mean, I'm assuming everyone is interested in having this dialect, and the first probably, if anyone doesn't want this dialect at all, that's probably something that we want to address first. So if anyone has any objections, probably we'll start with that. Okay, I don't hear any. So, okay, and then the next one I had was like the name for this dialect. Maybe we can table this and take it later, but we are proposing TCP for this. But if anyone has any other suggestions for that, that would be nice to hear as well.
Yeah, let's not talk about names. I think we have bigger things to talk about.
Okay, we'll table that. So, okay, then we'll get to these points, or we can go over these discussion points, which we thought were important, or something else we want to start with. We're okay with that.
So for me, I think that the last two, the layering and, what we expect to kind of lower into this and what are like the inlets, outlets, layering, I think that's the most important question for me, because things like stability are informed by what we want to do there. And, even almost like the incubator stat, it's kind of, I think it all depends on that. So I think we should talk about that.
Okay, fair enough. So yeah, I have I put up a diagram. It's there in the next slide. This is the layering or end-to-end compilation flow we are proposing. So we can talk about this. This will probably define all the things like how the front ends how we expect the front ends to interact, and also how TCP is going to interact with other dialects in MLIR. So yeah, we can talk about this probably. So the idea here is, I mean, all the front ends, or whichever we want, all the front ends can have like two lowerings, one to stable HLO and one to TCP. And stable HLO will provide the stability guarantees that the front end want. But TCP, on the other hand, will provide like a wholesome LLVM code gen flow, like everything within MLIR. There'll be a way to do code gen through this. So that is the advantage with TCP. But, and again, this relates to the stability guarantees. TCP, initially, we are not proposing, we are not guaranteeing any stability, but later, after the development phase, it should be stable, not as a stable input format, but it should be pretty stable.
So one question I have about this diagram is there is a transitive arrow from stable HLO to TCP. So why is there a need for direct lowerings to TCP?
So we believe, I mean, stable HLO is going to take more time to make changes, right? Like if something new comes up, we can't wait for like the next release of stable HLO to get that through. So our belief is that's one reason we want like direct lowering to TCP so that we can get things done faster. Stable HLO will eventually catch up, I mean, as far as I can understand, but it might take much longer for that to happen.
Okay, because I think what I'm thinking about is like, maintaining these two paths in parallel is because, I mean, the lowerings to stable HLO and TCP are going to be like, at least speaking from the Torch MLIR side, it's going to be like roughly the same. I mean,
But
given the direction I'm
they are
seeing.
not, Sean, I don't think they are concurrent lowering that are doing the same thing. They are complementary. I think on this, like the idea of what's presented here is that you use the stable HLO path and you only add TCP for things that are not supported by stable HLO alongside the transitive one.
Okay. Is that what you were thinking, Raghavan?
No, I mean, okay, we can think of, do like that as well. But one difference there is if you want a dependency, as far as I can understand, stable HLO is going to be in a different repo under OpenXLA governance, right? We are proposing TCP to be under LLVM, either incubator or in MLIR tree. So if you want just dependency on one dialect, one repo, you can just take the TCP path, right? Then you'll have to have an entire lowering through TCP. But if you're okay having this extra dependency on a repo that is outside LLVM umbrella, then we'll have to go through stable HLO. Those are the only two differences I see.
So the like one thing that's worth pointing out here is, I mean, that's essentially using the sort of like privileged position either in tree or like to a degree as like an incubator to sort of be like, yeah, there's like one less, dependency problem. And kind of this happens today with TOSA, but even for that, like with Torch MLIR to TOSA, but even with that, I mean, I think in the fullness of time, we do want a stable input format because like in reality, like a lot of these paths, there is going to be skew and, kind of in the, for some periods. And like, for example, like I guess Stella, you're probably, I see you're lining up to talk about this.
Yeah, I think that I really want to understand what the ideal layering is. And then from the Google perspective, we're incubating stable HLO where it is under OpenXLA governance because we're, basically what we're saying is that we want open governance on it. We've not concluded where it goes from there in the fullness of time. So I just want to make sure that bit is set, like, we're talking about kind of two new things that we need to dance around over probably the next 6 to 9 months. And we've got certain business and community constraints that let us make decisions about stable HLO. Those may not be compatible, but there is an intent to move this more community bound. So but I do agree with Sean's point. Like, it is, we have seen this happen. The privileged position of it happens to be in tree, so you kind of smash more things in that direction is not the best. So maybe if we could keep the conversation a little bit abstract in this construct of like what layering is there, and then we might be able to, like, we have a lot of flexibility as to what we can do in terms of where things land eventually. But I'm also trying to be somewhat careful. I don't want to enforce anything on the community's will here. And I think that there's a level of independence and control that's at the root of this. And I don't want to undersell that because, I'm speaking from a more privileged position.
Okay, yeah, I mean, but my first point about this stable HLO being, will take time to get updated is still valid. So that's one of the reasons we wanted to have this one path through TCP as well. But yeah, if you think that stable HLO will always be in sync with what Torch wants and what we have in TCP, then we can get rid of that and always go through stable HLO.
Yeah, I mean, I think the stable HLO will end up having an extension mechanism that is more suitable for front ends. Like, this gets to my everything at the front end is pragmatic at the end of the day comment. I think it's really so the model that we're thinking of for that is something more akin to how extensions flow through a standards body. Like, there can be named extensions, there can be there becomes roll-up releases of things that have gotten acceptance. None of this is final. These are all conversations in progress that I'm just telegraphing. So I'm not sure that slow to converge to a version number is probably a desirable design point for stable HLO, but slow in terms of it'll take a year to add a new op is not. Anyway, let's talk about TCP. I don't want to take the oxygen out of that.
So just so I can.
Yeah,
go ahead.
Well, this is Prasant. I have a very naive question. I mean, I haven't gone through the proposal or the document. Maybe a naive question that I have is that I see that the plan for TCP is to take all these 4 dialects, JAX, Torch, TensorFlow, and Onyx, whereas stable HLO is only having the edges from the JAX, Torch, and TensorFlow. So I think there are Google folks here as well. So are there any plans in adding the edge from Onyx to the stable HLO? If so, what is the rationale for going into TCP?
Oh, actually, I wanted to clarify one thing before that. So this is not presenting all the edges, all the possible lowerings. I'm only talking about like what TCP brings in to this picture. So there could be other edges that TCP is not involved.
I believe Onyx to MHLO already exists in some form, and so it wouldn't be surprising that Onyx to stable HLO could exist. So I think we can pencil in that arrow.
Okay, fair enough.
Okay.
So also, I go on.
Yeah, just wanted to comment on the edges between stable HLO and MHLO. We hope that they'll be fairly close to each other. So as a result, if something has a path to MHLO, through the connection from MHLO to stable HLO, they will have a path to stable HLO.
So the HLO star HLO dialects, I imagine they will be like pretty guided by the current HLO IR, right? Or at least whatever exists in that area is going to be reflected almost one-to-one with any kind of HLO dialect. And TCP might not want, so this was one of the things that the document had, is you don't want to, what was the word we converged in the end? Initially it was obscured, but
Naive,
I think niche.
Niche, yeah, niche one.
Right.
Sorry.
Yeah, which are specific to HLO or specific to Torch or specific to Onyx, right? But trying to use TCP as a common part of the dialect, and then the others are the differentiators, it puts a lot of stress on the tools to develop their own operations and then maybe move this operation across dialects. It's something that doesn't scale, right? So I think maybe a simpler thing is what Stella was saying is, things go down to stable HLO. We have, as in the open XLA community has some kind of oversight to that kind of thing that stays and how it moves. But then what is TCP adding to that, right? If all of these front ends have a connection to this new community-driven dialect, then what is the point of the second community-driven dialect that is reasonably similar and just adds effort?
So I think as Stella said, like stable HLO is being shaped by certain forces that are not necessarily going to be present in TCP, and so I hesitate to just sort of treat this as, okay, well, there's 2 GitHub repos that are just, or whatever, that are going to, they're just blank slate, new projects that are community driven, like ML compilation things. There is a bit more nuance to it.
Let me comment on this a little bit from the stable HLO perspective. First of all, as Sean is pointing out, there are existing requirements that gave rise to stable HLO. And from what I understand, on the TCP side, we are currently trying to decide what kind of compatibility is of interest. So to be more concrete about the compatibility requirements on the stable HLO side, we're looking at significant backward compatibility period. By significant, I mean like 6 months, a year, 2 years, maybe like 5 years. So stuff like that. And that's what's going to be really important, from the TF, from Jack's perspective. That's one thing. Another thing that I wanted to comment on is stable HLO's relationship with HLO. So HLO historically has been pretty much driven by XLA's needs, which also involve TPUs, Google's internal ML accelerator hardware. But with stable HLO, we have bootstrapped from that, but we don't intend to stay tethered to this. So our goal, with positioning stable HLO is, this open thing as a separate thing from, to have two dialects, stable HLO and MHLO. The idea was to evolve beyond what we have. So I don't know, for example, people say that gather and scatter in HLO are like too complicated. Okay, great. Let's discuss how we can simplify them. And perhaps, HLO in the TPU compiler can stay in the current shape as it is, because it's a better fit for TPUs. But that won't stop us from evolving stable HLO. So overall, what I'm trying to say, I guess, is that in many ways, we have a lot of flexibility on the stable HLO side. And if we definitely plan to participate in community discussions around TCP, because they'll help us align the two offsets. And the only sticking point is really compatibility guarantees. So for business reasons at Google, we absolutely want backward compatibility, like the strong stuff. But everything else seems very alignable, and I'm really looking forward to doing everything what's needed on our side to make sure the ops are compatible, like gather, scatter, broadcasting decisions, dynamic shapes, this whole stuff.
Yeah,
So,
I think. Oh, go on.
Oh, I was just going to say, I think another way to look at this is to say, what if we relieved TCP of some of those requirements and focused it more on transformations and mid-level optimizations? It makes more sense versus the ultimate ingress dialect. So it's like every dialect can stretch to be an industrial strength ingress dialect, but they give something up in the process of doing so, and they give up. They're going to collect cruft. They're going to collect things that were bad ideas and have to be preserved for 5 years. Things that you really want your transformation dialect to not have. So there might be a freedom aspect to separating these things that is important.
Yeah, I think that's what I meant. Is there seems to be in this discussion on the document and on the forum, there seems to be two camps. One of them is thinking about the lowering into the dialect from the front end, and the other one, where I sit, is to consuming this dialect into some transformations, right? And these are different. I mean, the signed versus signed is a reflection of that kind of discussion. And I agree what you said, Stella. Is if TCP is a generic high level, that we don't need to lower all of the stable HLO, all of the Onyx, all of the Torch operators to it, but what we lower can now be run and optimized by other passes that are not standard in the framework, right? So say you take Torch MLIR or you take IRE, and I plug my transformations. If you have TCP plus Linaug in there, then I can do stuff that is specific to my hardware, is specific to my requirements, that IRE doesn't do, or the Torch MLIR doesn't do. And if I want to do the same transformations on both Torch MLIR and IRE and Onyx and whatever, I don't want to code for each one of these dialects. I want to code for TCP. So from my point of view, being very selfish, if TCP is like a minimum common, like the intersection of all of these things that has a semantic representativity enough that can, just like Linaug represents the generic stuff, TCP will be a few generic operations that I know what they are, that they are common across hardware. And then I can just look at the shapes and see how I fit this into, I don't know, registers or cache or GPU lines or FPGA area or whatever, right? So this will be a transformation. In my point of view, this will be good as a transformation IR, much more than just a lowering of the operators from the front end, because the other dialects are better than a generic one for this in that view.
Yeah, for what it's worth, that's our main goal as well, is to have this not an ultimate ingress format, but a transformation-oriented dialect.
I've come in to make over here, and I'm not wearing my Tesla hat here, but more like I have done a lot of work in this area hat, and it's mainly about the arrows in the drawing over here. All of these arrows are a significant amount of work, potentially multiple person years, and even with this table, like Tesla, it's quite hard to keep them up to date and ensure that they don't break and keep up with the fixes when things do break. And I'm trying to get a sense of whether there has been some kind of an estimation of what might be the effort needed to keep everything up and running, even as something like TCP evolves at a much more rapid pace.
So actually, maybe we can take a step back. So like the folks at Cruise are really pushing this hard. And so I think understanding, making sure that we at least cover their requirements is going to be like, an important part of making this move forward. And so could you folks maybe talk a little bit about, what you want to plug this into, what your plans would be over like the next, 6 months, 1 year, in terms of like concretely, like we would have to write this code to do this or this code to do that.
Yeah, sure. Yeah, the main part we are going to focus on, I was probably going to comment on that, is to begin with, to have Torch to TCP and then TCP to Lineage lowerings at least, right? So that is the path we'll probably first implement if that's the use case we really want right now. So so we'll definitely contribute to that, but other lowerings we can add as need comes by, but this is the one that we are really looking for.
Okay,
yeah,
so go ahead.
So I was just going to add a couple of things. So also another thing is that for the next 6 months to a year, we'll mainly be focusing on inference, although we want TCP to be something that does support training as well. Our main focus would be PyTorch inference on NVIDIA GPUs and our own custom accelerators that we have internally. And we would also try to lower some parts of TCP to cuDNN and cuBLAS, for convolutions and matrix multiplies. And the other thing, the other box that isn't here, but we'll probably leverage quite a bit, and Raghavan, correct me if I'm missing something here, is that when going from Torch to TCP, we would leverage the existing TOSA lowerings that already are present. So it's not like, so we would maybe potentially even start by writing a TOSA to TCP lowering, and that would give us relatively, would give us a non-trivial surface area right away.
Yeah, so I think this synergizes really well with Torch MLIR, and we can talk about some specifics. I just want to throw a few things out there. So yeah, I think if there's a robust TCP to Linux path and the TCP handling of dynamic shapes is as good as Linux is, then that would be really great for us, because then basically as we add TCP lowerings, essentially we can delete the Linux ones. So that would be it's kind of like a net zero.
Yeah. I was going to comment the same thing. Like it doesn't.
Yeah. So that would be a great win. One of the reasons that hasn't happened, so Torch supports Torch to TOSA, so Torch MLIR supports Torch to TOSA, but because TOSA's is pretty static shape oriented, we haven't been able to just blanket delete parts of our Linux lowering in that case. And so this is, if TCP can, be different in that way, then it would be, definitely very welcome. And I think if there's a TCP to TOSA lowerings for, the subset of TCP that, it makes sense to lower there, then, which I assume would be everything that Torch MLIR would support, then as that comes along, we can also sort of, delete parts of our direct TOSA lowerings also. So that is a huge win for us too.
I think that aligns with what we had in mind, all those, what you said. Yeah.
Yeah, so in that case, even though TCP is, call it like unstable, but I think it's not necessarily going to be like more unstable than like Blenalgan TOSA lowerings. And so I think it should be pretty, on that dimension, sort of no harm done, approximately.
Yeah, I think after the development phase, we don't see it as any more unstable than, say, Lineage or Affine or something, right? But until that happens, that's probably going to be some changes. But yeah.
There were certain operators and not just Torch, but other frameworks too that do not legalize fully to TOSA. They can think of something like max separation or top K. These perform something like a sort operation, and there's no way to actually define some kind of a subtensor behavior like that within TOSA. Something like that connected through the TCP path directly from Torch might be really useful to sort of connect everything together and bring them down to the level of Lineage or something and make it work. In addition to dynamic shapes that Sean spoke about.
So it feels like we are kind of getting a grasp on the layering, at least in like one or two of these important flows. Maybe it's worth at this point talking about some of the transformations and other things that we, that we want to do here.
Yeah, okay. Actually, I didn't have it in the slides, but it was there in the document. I mean, some of the one main important transformation that we would really want to support is the fusion, op level fusion, where you can combine ops into a region. And I mean, it doesn't define how we code gen for that, but you could map it to like a library or do special code gen for that. But really want that like op level fusion, and you're thinking about like algebraic simplification, layout assignment, buffer assignment, and stuff like that. So those are the things we see TCP doing, and also to add to, I mean, some of the comments there were like we wanted it to be like the transformations to be complementary to Lineage, like not really add anything that's Lineage is already doing, so that this TCP to Lineage path actually in combination will provide everything that we want during Virgin.
Right. So that's maybe a point I had some questions about, because I'm wondering whether it is necessary to limit the transformations that TCP can do. It seems you're interested in having a TCP.matml. That's kind of like the central op. And it seems that TCP is going to be the place that lowers to different libraries. So TCP.matml goes into a function call. One of the use cases that I think is interesting is basically be able to tile and fuse stuff, and then be able to call a library, because maybe you have a big hardware hierarchy and you have a super good implementation for level 3 of the hardware, where the data is known to reside in L3 or whatever. And that's where you want to call your library, meaning that you need to tile, fuse, and then call the library. And so if TCP itself is not the place where we do the tiling, basically tile a matml to a matml, and if Lineage has to do that, then it means we need to go back to TCP to call into library. What do you think about this use case?
Actually, we have a similar issue, right? That we have function calls to a library, libxsmm, and the shape of those gems are specific, and they are the tiles, right? But the shape of the tensor is much larger, and how you traverse this tensor if you linearize it, or if you try to change the dimensions across so that you reuse level 1, level 2, level 3 cache, those are two different problems, right? So finding the tile and the locality for the gem is one problem, and finding how you traverse the outer loops so that the other levels of cache are kept busy, it's a different thing. So in the TCP, you would have a matmul that you give some dimension, and that will be a library call, right? But we want to say, look, no, that's not what you meant. You want this matmul, but we know that this is not the most efficient way to do this matmul, because you have these other loops here, either a linaug loop or a fine loop, that I know that this is traversing the wrong way because this is either column major or some other shape that is wrong, right? Convolution has all of these different shapes, and you know, one implementation is much better in a specific shape than the other. So if you bring in one, do you try to reorder these loops? Do you try to reshape this tensor? And this is a mix of a matmul, a operation matmul, and an actual nested loops, right? And are these nested loops affine? Are they linaug? Do we have a loop in TCP? Or do we just lower this matmul into an actual multiply and add as a linaug generic? So all of these problems, I think it will depend on how we represent this matmul and how we represent these loops. And this is, to me, this is the interesting part to solve when designing TCP with linaug, is because we get to use these parts without reinventing the wheel.
Yeah, it sounds like a lot of the direction that I was seeing in the thread in terms of design decisions would basically mean that the TCP ops would implement a lot of the transformation interfaces that we've invented in the linaug space. And that means that TCP, there was a recent thread by Alex Belayev regarding adding like linaug.elementwise or linaug.reduce or some things like that. And I think that kind of seems to look a lot like, it seems like that would be the type of ops that we would actually have in TCP. Or does that make sense to folks? Just throwing that out there.
I think that was the idea of the unary op and binary op, right?
And I think there's space in TCP also to, for example, continue to use destination passing style, but have like top K ops, or things that aren't structured ops or aren't even easily they don't even like necessarily implement the tiling interface, or I don't know if top K does, but and so in some sense it would be kind of like following a lot of the design principles of linaug, and implementing as many interfaces from that space as possible to enable transformations, but also having a bit more flexibility in terms of what goes in there, so that you can pull in a broader set of operations from front ends without having to sort of like generalize linaug, or for lack of a better term.
Mm-hmm.
Right. I think that's a good point. So one op in particular that I'm interested in seeing ideally is a gather, but a gather like a TCP.gather, I think would be super interesting to kind of prototype. The reason is that today there's only one dialect where you can put ops that work on both tensors and buffers, and that's linaug. And if TCP makes this design decision, it becomes possible to write a TCP gather without having a tensor.gather, a memref.gather that has some special semantics. And then where does the lowering to something that turns into loops happen? There isn't such a thing for the memref dialect, so it becomes quite tricky to land a gather today. A TCP.gather seems like a nice thing to try and spell out, including the lowering to something that's executable.
I have a comment here. This from speaking from experience, but if you look at this as some kind of an intersection of two funnels, maybe you want to think about, are you trying to maximize the input funnel coming from the frameworks? Are you trying to maximize the output funnel, optimizing as much as possible for code generation? Because it can be hard to do both without one constraining the other in some manner. You can try to aim to maximize how much you can get from the frameworks, but it might come at the cost of being constrained in some way, the number of transformations you can perform during code generation. Trying to optimize for both can be a very hard thing to do, very painful, because the errors in this picture are each extremely costly to implement and maintain and keep up with.
So I see this as a case-by-case basis. Is one of the comments I made in either the document or the thread, I can't remember, is if say Torch lowers to Torch dialect, and then part of this Torch dialect goes into the TCP dialect and Linhaugenifine and some others, right? But there's still some leftovers of Torch around because it's specific to either Torch or the model or the hardware. Then I try to run my passes on it, and I'm only going to look at the dialects that I understand: TCP, Linhaugenifine, etc. If I know that in Torch there are some operators that Torch doesn't want to change because it says, you know, I don't want to guess, but I know, and I then pass a pre-pass that converts from Torch or any other into TCP, do my transformations, and maybe either convert it back to Torch or just leave it as code, because I know that in the end this is going to generate the correct code for the correct target, right? All of these things are, of course, many to many, right? It's really hard to implement all of these things. But if the surface of those transformations are very small, are like this, there's only 2 operations in, or 3 operations in each one of these dialects that I know how to handle and I know has a good result at the end, then for me as a transformer engineer, I can pay that cost because I know that this actually improves code generation for my targets. So I think the funneling, I don't want us to funnel everything into TCP and then out of TCP. I don't think this is the right abstraction level. I think there has to be everything into a set of dialects that collaborate together. For instance, as I was saying before, the loops and the matmul, maybe we can convert a matmul to a loop of Linhaugs and a loop of Linhaugs into matmul without losing semantics and information. If we can do that, then perhaps we can do more powerful transformations.
So one, just reacting to your last point, the going back and forth, there is a whole class of ops for which things are relatively easy. Where it becomes really, really tricky is when you want to define some high-level op in TableGen C++ that has some attribute, and the name of the op plus the attribute has some special semantics. For instance, the padding of a convolution. Like if you specify a convolution with a padding attribute that takes some values, it becomes extremely difficult to go from a linear generic to that. And the main reason is that that's an inverse problem for which I would claim we don't want to spend the effort writing all the possible matchers in the world. They are extremely hard to write. So that class of ops is actually quite tricky. The other ones are really simple, like point-wise, element-wise, map, reduce, matmo.
Yeah,
conv.
Yeah, I was thinking about those. I agree with you.
Yeah, on the topic of the ops, I think also like in Torch MLIR, we actually have this dialect called TM tensor, Torch MLIR tensor, which has a cumsum and or scan and a scatter in it, and eventually it would need like a sort and a blah blah blah. And so I think if TCP could also be a place to home that as well, and a place to put those ops, that would be a great outcome for us. Because right now we're kind of like sneaker netting that dialect across different projects, and it's horrible. So I think there's a definite value add to having that.
So
one of the things that's come up a few times in various contexts is that if there's a possibility to make, Linux currently has a somewhat disjoint set of front-end ops defined in OpDSL and whatnot that are very interface based and becoming more so and whatnot. One of the things that keeps coming up is that is there a graduation trajectory for those in some fashion that using interfaces and other techniques we live at a higher level. And I don't know if the answer is TCP, but this conversation seems to be heading that way.
So one thing that we have always found difficult is to take a hard stance on what a element-wise should look like, because that's where we start touching semantics that are important to both people who want to program it at that level directly. So it gets into language designy type of things where many people have different opinions. And the second aspect is that that's also the level of abstraction at which we want to do these algebraic rewrites at the Tasso style level. And we don't have much experience with those, so we really didn't want to put too much of a stamp on these named ops. So that's kind of a top-down, bottom-up problem. So you go top-down, then you go bottom-up, and now it's probably time to do a good top-down design of how we should spell these ops such that they are indeed good for algebraic rewrites, and that seems to be very aligned with what TCP wants. But I do think there's going to be a bunch of top-down, bottom-up iterations to actually make sure that the transformations below also connect properly.
So that does remind us that we will actually have to resolve the point of element-wise ops at some point, which tends to be somewhat controversial and mixes in with broadcasting and other stuff. Probably not in the next 15 minutes.
I'd like to bring up one other major point in terms of the process of designing this dialect is the choice of which ops go inside of it. I think we have a lot of excellent prior art here in the HLO space and in the TOSA space that's gone into understanding what is valuable to model. But we will still have to make decisions like, do we have a matmul op or do we have like a matmul, but you kind of can choose an arbitrary set of dimensions to reduce along and stuff op like mhlos.general. I think we will have to make such decisions, and just wanted to bring up that, that is like a non-trivial design effort to consider all that. And I don't know what principles we're going to have for that. So just want to put that out there and see what people's thoughts are.
Could you maybe summarize your question a little bit?
Yeah, so I think the question is do we have like a matmul and a batch matmul op, or do we have like something similar to mhlos.general? And how are we going to make those decisions? Or are we going to say, oh yeah, well, all those are special cases of conv, so we'll just use the conv op for those? I see Sanjay shaking his head.
Yeah, there are also special cases of a reduction with the element-wise operation fused into it. So,
Yeah.
I mean, I think there's going to be a matter of taste. I don't think we can kind of pre-decide an algorithm by which we'll make these decisions. But I think, as you said, we have a lot of latent, knowledge in the community. All of the experts are here, so I think we can figure something out. It's probably going to be a balance of what can be practically lowered to the backends that we care about and what's needed by the front. It's basically all of the things that we just discussed, right? It's a hard problem, but I think we have enough folks in here who know how to solve it. So, I mean, I think we only have 15 minutes or 10 minutes actually. So can we talk a little bit about the process side of things? Like how are we actually going to bootstrap this, and how will we have deeper technical discussions going forward? So Raghavan, do you want to go back to some of the other slides that you had?
Yeah, so I mean, so yeah, probably the first one is then as an incubator or entry. That's something that we have to make a decision on, and then who is ready to contribute and how we go about from here.
And in terms of who's ready to contribute, we were looking to have, at the very least, some folks outside Cruise who would, be able to review PRs as they go in. But ideally, maybe even deeper collaboration than that.
I'm happy to help review code as needed to help smooth landing stuff. You were also asking about technical discussions. These slots that we are in right now, the ODM has been fairly unencumbered recently. So if you want to meet weekly for talking about stuff, most of the time you can reuse these slots. That's fine. At the time we originally proposed TCP, but we didn't get enough traction. We also created a channel, a category on Discourse that still exists, which was called the TCP Work Group. So if you want to discuss everything specifically about TCP, write RFCs and proposal, you can continue to use this category on Discourse. And if you want to have the working group of a really weekly sync, you can also set up a different slot of a public meeting for it if you prefer. Yeah, those are all my input right now. We also have a Monday at 9 a.m. Pacific slot in Torch MLIR if that's useful. Maybe we don't want to monopolize that slot, but for Torch MLIR adjacent topics, it's very welcome.
From the stable HLO team perspective, we are extremely interested in participating in discussions, doing our best to align, the semantics of ops. As I mentioned, we want to simplify, stuff like gather and scatter, and the closer stable HLO and TCP will be, the easier the conversion will be. And speaking of the conversion, like bidirectional conversion between stable HLO and TCP, the moment we have something in tree, the moment we will have a conversion in the stable HLO repository. So extremely interested in that stuff. Sign us up.
So Eugene, when you say bidirectional, sorry, go ahead.
No, I think you have a question too, Eugene.
Okay, great. Yeah. So I was going to say, in terms of bidirectional conversion, right? What about things like TCP.fusion or things like that, right? Like, is it always going to be possible to convert TCP to stable HLO?
Well, I guess this is what we're going to find out.
Okay, cool.
I'd love to align the offsets as much as possible.
Yeah, definitely stable HLO to TCP totally makes sense. I'm more concerned about the other way, but we can hash that out. So on the question of incubator or entry, so my personal experience with it's not just mine, our community experience with the Torch MLIR process, it let us, being an incubator gave us sort of a degree of freedom to move very fast on certain things that I think proved to be really useful. We've made one or two very, very major pivots in the design, that required, deleting half the code base or tearing up, the dialect in a huge way, that I feel like it benefited from that a lot. I'm not sure if TCP will, if that applies. I definitely think it's especially for when you have a small focused group that's kind of needing to iterate quickly on things that, don't have necessarily a ultra long-term time horizon, and are just bootstrapping. It's definitely valuable. Also, it's a great place for a simple example is you probably want scripts and stuff to check out Torch MLIR, compile a model, lower it to TCP, and run things and whatever. And that kind of stuff is really, really hard to do in tree. And in an incubator, you just have a directory like tools or something or utils, and you just do it. So I think some of those project-y things might make sense as in an incubator.
Some of the things that wouldn't is if we're doing major surgery across Linnow or something, or when I think that there's a certain level of the initial design concept getting written down and iterated on in an incubator can be really freeing, but we should, if we go that route, we should really look at when it when it needs the exit criteria, needs to go upstream. And that's really probably if we start making joint changes to the surrounding dialects. Yeah, 2 cents.
Yeah, like one thing that came up in there is the custom tensor type. And so I think this could solve the sort of like abstract tensor problem or like init tensor problem in Linode. And that would probably be this type of joint surgery. So yeah.
In terms of dependencies between the repositories, are you thinking of this as Torch MLI would depend on the TCP incubator repository if that's the direction, and then you would put the lowerings in there, or do you expect it to be the other way around?
So from like as long as we are holding actually that's a good question. I mean, we could slot it in just like we did for MHLO. So I mean that's sort of just like a known amount of pain, and process involved. I think we would have to talk to the community about like our community to see whether we want to take that on, but generally I feel like that would be doable. Having the incubator take the dependency on Torch MLIR and implement the lowerings externally is another possibility that I hadn't considered, but that could also be interesting.
Does it make sense to initially consider a non-critical path within Torch MLIR itself?
Sorry, what was that, Suraj? I didn't understand.
What do you mean by non-critical path?
We have a bunch of background noise. I was going to suggest whether it makes sense to start initially from within Torch MLIR and sort of concretizing TCP in there, and then have it become an independent incubator project, because there seems to be a lot of connectivity within Torch MLIR to begin with.
Yeah, that would actually be another option. So I mean, we actually historically we did have a TCP dialect in what eventually became Torch MLIR, and so just from a project management perspective, if we wanted to do that with a clear graduation extraction plan, I think that would be like one less repo flying around.
Yeah, that also
connected does within Torch MLIR without the kind of inter-repository dependencies, initially at least.
Yeah, absolutely. Reduces the administrative overhead, definitely.
Yeah, we would want to have a clear exit criteria and a clear separation, of course, just so, yeah.
So this ties in with what I was going to suggest is if the existing front ends can, with their own dialects can say, look, this is the list of operations that we think should be in the TCP. We just set, a few guidelines, like it has to be, sightless because it's a transformation IR. It has to, these are like probably like MATMUL and etc. And then if we can get the intersection and start working from there, right? Because I'm guessing there's going to be a lot of intersection between what the stable HLO and what Torch wants TCP to look like. And if we can start from that core and then expand or contract as needed, then perhaps this will be like easier to just build one long TD file with all the operations based on that list and then iterate from there.
So Eugene, would it be a problem for you to take that dependency on Torch MLIR to, while TCP is sort of being brought up in there?
So to me, yes.
So
to me, yes, it would be a problem. And I see it as a concern for the community and the collaboration in general if TCP doesn't start in MLIR. So first, Torch MLIR is not MLIR. It's not, for me, the same community or the same project. I'm not subscribed to this and I don't review code there, right? Not because I'm not interested, but because I don't have time. And like starting there doesn't position it for me the same way. If we start TCP inside MLIR itself, just like Linux is, it makes it trivial for everyone to take a dependency on it. Everyone that has an MLIR dependency can easily take it. That was the argument to put TOSA there, to say, well, if we put TOSA here, then everyone that has a dependency on MLIR can easily target TOSA and interact with it. So I think a better balance is that the dialects should be in tree, but that doesn't mean that for the end-to-end path, experiments, prototype, integration, Torch MLIR is not a good place. You mentioned script earlier, Sean, and I think like keeping the lowering from Torch MLIR to TCP to Linux to to TCP, and then everything running with integration script in Torch MLIR. Seems like good, and you avoid the one extra incubator, which means one less moving pieces in the ecosystem. And we can still all collaborate on TCP, just like we do on Linux today, in tree.
That seems like a nice sweet spot.
One concern that might be is that as we bring up TCP, it might, while it's still a fairly new project, we might be increasing the burden on folks who are working on other parts of the code base, like, presumably being in tree means they would have to update TCP when they change APIs. So is that a concern? And B, does that mean that is there a way to integrate it in a way that is not built by default and then there's a graduation pathway, and it's just like they have experimental targets in our VM?
So the feeling I'm getting, we're out of time, is that I think if we iterate a bit on discourse with Chu on this, and then next week have another meeting, I think we will be able to get consensus and break ground and like make dear all the things. At least that's my feeling. So I think we should aim to do that.
Yep, we're out of time, so probably we should leave it there. I think we made a lot of progress. I don't know if it's enough to have a full conclusion. We're gonna try to take this to discourse. Continue. I don't know if someone can summarize the points we have and the leftover question on discourse. That would be great. Or we can summarize it in a doc first and then publish it on discourse. And we can always continue next week if in-person meeting is needed. But hopefully we can, start making progress and implement stuff. And Sean left, so out of respect, I think stop discussions here.
Bye, everyone. Thank you for the chat.
Bye, everyone.
All right.
Thank you. Thanks, everyone.
Thanks, everyone.